Hello and welcome to the channel Higher Flyer. Today we are going to discuss volume of revolution. So we have question the curve y equal to under root x with 0 less than x less than 4, this is domain, is rotated about the x-axis. Find the volume of revolution. So I need to demonstrate this one. So let us we have demonstration. So here is the x-axis and here we have the y-axis. So I can write it x-axis and y-axis. So that is y-axis and that one is x-axis. So we have the function y is equal to under root x. So how does it look like graphically? If we draw the graph of this function, so it will look like this. So we can plot the numbers. So it's 0, 1, 2, 3, and 4. Well, so what does that mean if it is said that that is rotated about the x-axis? So rotated means it is rotated 360-degree around the x-axis. So this thing should be rotated around the x-axis. So how we are going to rotate that one? So it would look like, when it is rotated, it would look like uh, so it would look like this one. It would look like that one. Okay. So now what actually we have to find? We have to find the volume of this shape. Volume of this shape. When it is rotated, we have to find the volume of that one. Okay. So you can see over here, if I draw it separately, if I draw that thing separately, if I draw the same thing separately, so you can see that it would look like the kind of tiny cylinders. You can see that it would look like the kind of tiny cylinder inside this one. So there would be a lot of small cylinders inside this shape. So you can see these cylinders over here. These are small tiny cylinders, right? There will be the small tiny cylinders inside that shape. Okay. Okay. So these kind of small tiny cylinders inside that shape, if we are going to find the volume of a single tiny cylinder, that will be equal to, volume is equal to pi r square h, right? So that is the volume of tiny cylinders. So now in case of that one, we need to integrate, because we have to find the sum of all these tiny cylinders. In order to integrate that thing, what actually we have to do, we we need to integrate it from 0 to 4, as it is bounded from 0 to 4, so we need to integrate that one. So I'm going to integrate over here from 0 to 4, and that would be equal to pi r square, and in this case the height is the thickness of that one. In this case the height is the thickness, so this will be the small thickness. So small thickness could be written as dx, so it would be like pi r square dx. Now what will be the radius in that case? The radius is actually the distance from this rotation point to the edge of that point, and that is actually the x. The radius is actually the x. You can see that the radius of that one is equal to y. So the radius of that one is equal to y, right? So y in this case is under root x. So we can replace all these values and solve the integrations. As pi is constant, so we will take pi outside of the integration, that is pi 0 to 4, and our radius in this case is y. Radius is equal to y, and y we have under root x, right? So we can write it under root x square dx. Now we will apply the simple rules of integration, that is equal to pi, and it is bounded from 0 to 4, that is x dx. So now you can integrate that one, that is equal to pi is equal to x square over 2 from 0 to 4. Okay, so now we will apply the limits, and that becomes pi, and that is equal to 4 square over 2 minus 0 square over 2. We will apply the limit, right? So that becomes pi 16 over 2, and that becomes 0, and that will be equal to 8. So now we have volume is equal to 8 pi unit cube. That is our volume of that shaded shape.